Hi everyone. Today the topic is density of states of one-dimensional structure. Density of energy states of quantum confined structures. Today one-dimensional structure quantum wire is considered. In quantum wire, the electron or the particle is allowed to move in only one direction and it is confined or restricted to move in the two directions. Let us consider this wire, a one-dimensional quantum wire is considered. Let the length is taken as L and this is L plus dl. That is, if it is 10 centimeter as a whole, then up to L it is 9 centimeter and this is 1 centimeter. So here the definition for density of energy states of the one-dimensional quantum wire is number of available energy states per unit length in the energy interval dE. So here in this interval dl, the energy interval dE, we are going to find how many number of available energy states are there. So this is considered as L plus dl. Now within this quantum wire, the potential energy is zero and outside the wire, the potential energy of the particle is considered as infinity. So to find density of states of one-dimensional quantum confined structure like quantum wire, we are going to consider the number of available energy states between d. So L plus dl and L. Or even we can consider this as n plus dn, where n denotes the length. So here n plus dn minus n. So n and minus n get cancelled off. We are going to find dn only. So energy states, density of energy states, energy can be considered as E is equal to n square h square by, usually we will take it as 8m a square. Now here we are going to consider L square because the length is considered here. The length is that quantum number considered. Now dn has to be taken. So n or n square is taken aside and remaining parameters are taken on the other side. Therefore, n is equal to, we are taking square root. Therefore, 8m by h square, the whole power half, L square becomes L and E is with power half because we need dn. Therefore, we are going to differentiate n with respect to E. Therefore, dn is equal to 8m by h square. The whole power half is a constant. L is a constant. It is not a variable, but energy is differentiated here as half e power minus half and d. That is x power n is equal to, on differentiating, n into x power n minus 1. Now we are going to substitute this dn here. Therefore, density of states of 1D is equal to number of available energy states within this interval dn. Therefore, 8m by h square, the whole power half, L half e power minus half d. Now, per unit length, that is, L should be taken as 1 meter, that is unity. Therefore, L is considered as 1 here. And then, according to Pauli's principle, exclusion principle, each energy level is occupied with 2 electrons with spin up and spin down. Therefore, multiplying this equation with 2 into 8m by h square, the whole power half into e power minus half can be written as 1 by e power half, and then d. Now, these two get cancelled off. Now, h cross, that is reduced Planck's constant, is equal to h by 2 pi. Therefore, h cross square is equal to h square by 4 pi square. In this equation, we have h square. Therefore, h square is equal to 4 pi square h cross square to be substituted. Therefore, 8m by 4 pi square h cross square with half and 1 by root e d is written. That is, instead of h square, we have substituted 4 pi square h cross square. Now, this 4 cancels 8 twice. Therefore, we get pi square h cross square with power 1 by 2. It is taken out of this 1 by 2. Pi h cross, 1 by pi h cross is taken out. And then 2m is with this half. Power half is square root, and e is also with square root. 2me d. So, density of states of quantum wire, the one-dimensional quantum wire, we get this equation 1 by pi h cross root of 2me d. Therefore, here this energy interval d is E minus E naught, that is E minus E naught, where E should be greater than E minus En. E should be greater than or equal to E naught. So we get density of energy states for one dimension as 1 by pi h cross square root of 2m by this E can be written as E minus En. That E minus En is written. Therefore, if a graph is plotted with E along the x-axis and density of states along the y-axis, then the motion of the particle in one dimension will be in this way. Only in one dimension it will move. So it will be just like, seems to be continuous, but not in all aspects. That is what it is explained as a quasi-continuum. A quasi-continuum is a system that behaves as a continuum in most aspects, but not at all. So this is density of energy states of one-dimensional structure.